Hey, I'm Jared. I'm a Rubyist. Welcome to my stream. I run a company called Supergood where we build e-commerce applications using Ruby on Rails on a platform called Solidus. I have taken a few days off, but this month I'm doing all of the advent of code problems. We last touched base on day 13 where I was doing the transparent origami. Today I'm going to sit down and try and do day 14, 15, 16. I'm told 16 has quite lengthy instructions, but I want to catch up. And I'm had a lot going on at work and didn't sleep great the last couple nights, but well rested today. Gonna do what I can to catch up. 4 hours left. I might not come back for 9 p.m. I haven't decided yet today, but certainly then I'll just catch up on Saturday or something. All right, so let's get into it. Day 14. The incredible, sorry, before we continue, make sure I have my chat popped out. So if the one person who's here right now decides to talk, then I will see it. All right, chat's popped out. The incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even have the necessary input elements in sufficient quantities. The submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules, your puzzle input. You just need to work out the polymer, what polymer would result after repeating the pair insertion process a few times. For example, NNCB, and then a bunch of things. Let's just copy that. The first line is the polymer template. This is the starting point of the process. The following sections define the pair insertion rules. A rule like A, B, C means that when elements A, B are immediately adjacent, element C should be inserted between them. These insertions all happen simultaneously. Hello, Fig. Good to see you here today. We do some work with we work with people in London, so at work, so I talk to people in London almost every day. So starting with the polymer template NNCB, the first step simultaneously considers all three pairs. Cool. All right, now the pairs overlap. Note that these pairs overlap. The second element of one pair is the first element of the next pair. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of a pair until the next step. Okay. Polymer grows quickly. After step 5 it has length 97. After step 10 it has 3,000 something. After more steps it has more things. Taking the quantity of the most common element and subtracting the quantity of the least common element produces an arbitrary number that verifies whether we did this right. Apply 10 steps of pair insertions to the polymer template and find the most and least common elements in the result. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? Okay, I am immediately suspicious about what this is going to look like. Let's just take a glance at the input. It is relatively long. Let's get into the code here. We are working on day, what are we on? What did I say? Day 14. Part 1, we have a day 14 spec. We want to place our input in here. Let's just add that nicely. And we have an expectation for the final result, part 1 to be 1588. kind of want to build like a supporting class maybe to A, B, C means that when A and B are immediately, element C should be inserted between them. Okay, so we're inserting things. Can we just like G sub this thing? I mean, I feel like we're just gonna have to do the whole rest of it. It's gonna become too slow or something, but let's first get our starting, what are we calling this? Template. Let's use the words they use. Is going to be, or I guess we can split them both out pretty easily, and we call these pair insertions. I guess we'll call them. We get this by splitting this on double new line. Should give us our template and our insertions. And then our insertions, we probably want to do something more interesting to them. So let's take those and we're just going to map bang them. Oh, they're I haven't split them yet. So insertions equals insertions. We'll probably want to strip it, split it on new lines. Oh boy. Split it on new lines and map these all through something. So we have each line, and it's going to be line. I mean, we might as well just split it on this arrow. Seems reasonable. So now we can take a look at. So template. I think that's right. Insertions is going to be the insertions they gave us. Apple Watch is telling me things. So I mean, so let's see. I want to make a class that's going to be our, let's call it polymer. It's fun. We're going to initialize it with a template. I guess I should write the code that uses this first, but so we'll set the template, and then we'll apply a protein an insertion. I guess we can call it pair and something. What do we call these? It doesn't give us words for them. Pair and I don't know, element. It's the element to be inserted. And so we can do something like or we don't need to store it. Polymer equals polymer new with our template, and we'll do insertions take 10 each do, and we will, and and I guess these are pairs, so we can actually just, I think that'll work. Or we'll have to do the parens with the star, I don't remember. And we should be able to polymer.apply pair element, and then we're gonna need to call something on polymer if we get here. Dot answer. It's a variable name. But they didn't give us a name for what this thing is. And it'll be 0 for now. So this code should run. Right, but it doesn't actually do anything. So we want to like template gsub bang pair. I mean, actually, let's. I'm just too lazy to split it. AB equals pair split on nothing. I mean, that's. And this is just going to be A element B join. I guess we can expose template here. And that'll give us a seam for us to sort of test that this is working. So we'll try in there, try there. Or I guess I can just put it. Put it here. So we can say polymer.template, and we know they gave us step 2. So we should see NCN BCHB after step 1. Do we see nothing? Did I not gsub bang or something? gsub banged. Oh, well, let's get in there. See what's going on. Stop there, jump in there. A is what we expect to be. B is also what we expect to be. Element is what we expect it to be. Template is what we expect it to be. Oh, this doesn't contain CH. And what was that telling? What is going on here? And NCB after CHB. Okay. Maybe I misunderstood something. The first? Oh, it's the first one that actually does anything? Oh, I'm confused. Oh, I've totally misunderstood what we're doing here. Okay, so I failed to did a little reading comprehension failure. We're supposed to loop over the pairs of these. Got it. Okay, so that's cool. I made this make no sense. I think we'll just want to initialize this with the pairs, or the, is that what we called them? Insertions? I mean, the rules, now that I understand this. So let's call these rules. and we're going to initiate this, initialize, let's just initialize it here. But we're going to just convert this to a hash. Okay, and then instead of calling apply, we're going to call like step or something, and we're going to do something in there. So we have each cons in Ruby that allows us to iterate over each pair, but it doesn't make it easy for us to manipulate them. So how do we want to do that? Because the lookup is easy. This is tricky to do in a way that's not horrible. Let's go look at the Ruby array documentation, see if anything jumps out to us. Or enumerable even. So each slice, each cons, what is each slice? Yeah, that doesn't help us. Each entry. I'm not sure if anything's gonna really help us in this way. Oh, wait. I can just always take... I could do something really awful, maybe. So what if I do something like template, split it into characters. Actually, let's just split the template into characters. Now, we'll just join it back together on the way out. I don't know, do I need to do that? We'll find out. Because we can do template each consecutive to, and we're gonna want to map that, or do each with index, because I actually need to know the first one, and then map that. This seems convoluted, but let's try it out. We're just gonna polymer step. All right. So each cons. So we're going to be receiving a pair and a pair and a index here. I don't care about this right now. One thing I have realized is that I'm gonna want to do like a, oh, does that work, or do I have to do that? I want to split the indexes in the hash so that they're easier to look up here. Let's just pry inside of here and see if it's got us what we wanted in there. So inside of here we've got a pair and we've got a index. Cool. And we have rules. And our rules can be looked up by the pair. Amazing. Okay. So if we're on the first one, we're going to so this is what I'm going to do. So if we're on the first one, if I equals 0, then we're going to do something special. So we already know the insertion is going to be the rules indexed by the pair. If I equals 0, then we are going to return, just break open the pair, return A insertion B. Otherwise, we are going to just return insertion and pair dot last. To flatten it, and that could conceivably work. So Polymer is going to have template. I guess maybe template's not the right word for that, but and now it's going to have a template that is hopefully the right value. NCNBCHB, NCNBCHB, amazing. And we can Polymer dot step and Polymer template. We get NBCC NBBBCB HCB. Yes. This appears to be working. That looks close enough to this. Let's just eyeball it here. I guess I can actually underscore. Yes. Sick. Okay, we're amazing. Everything rules. So now, what did the problem tell us to do? It told us to 10 times do this. And then print out the answer. So that's going to, let's see. Cool. So we're going to take our template. We're going to tally. So I'm going to call this tallies equals this. And 2A. There's a min by and max by, so we'll use those. We'll say min and then we return max minus min, I think is what they told us to do. I obviously did something totally wrong. Let me just Windows got off center there. What was that error? Did you mean minus add? I'm trying method minus for B on line 30. Okay, that obviously didn't do what I had intended it to do. I expected that to return. Oh, I don't even need to do these tallies because I don't need to know what they are. Okay, not 2A, just values. Min is counts, min counts max with that. Cool, so that works. Bin solve day 14 part 1. Excellent. We have a winner. Day 14 part 1. All right, on to part 2. The resulting polymer isn't nearly strong enough to reinforce the submarine. You'll need to run more steps of the pair insertion process. A total of 40 steps should do it. Okay, so this is going to be an optimization problem. And we have an example, the most common element is B occurring that number of times, and the least common element is H occurring that number of times. Subtracting those produces this enormous number, and I assume that if I put that number in there, try to run my tests now. Oh, I gotta unskip the tests. In fact, we can even just focus it. Oh, right. So we'll extract iterations into a method there, and then our, let's get day 14 part 2. We can just override iterations here and say 40. I expect this is now going to take an amount of time that is not acceptable. So, how do we do this? I suspect this is similar to the optimization problem we ran into before, right? So instead of keeping track of the full string, we don't actually care. We only care about the counts of the different pairs within it. Yeah, that seems right. Seems like it could work. We're just keeping track of a bunch of numbers. The number of keys we could possibly have is relatively fixed. In fact, so like we don't even need to focus this spec. We can run both of these whenever we want. Doesn't matter. We're no longer going to keep track of the template. The template is simply a starting point. So we're going to have to want to build a, or we're going to want to build some kind of hash here. So, okay, that's clever. That's clever. I like this. So the hash is going to be, let's just set it up. And then we don't even need to, let's just clean that. Dot split each cons 2. We are going to thanks. Yeah, I try to do that where I can. Sometimes I can't see a path forward to doing that until afterwards, so I work on it more like I would if I were doing normal development, where I sort of build out the feature and then see where I can refactor. In this one, where it's just an optimization thing, I can kind of just share all the code and just do it more iterations. So it's fairly straightforward how I might parameterize that, because like otherwise my like implementation should work for both halves. So I'm just, when it's just a single parameter like that, I just pull it out like that. All right. Whoop. Lights changed. Lights weren't supposed to change. It's a sign of me doing this early. It's like an hour after sunset must be. back to stream mode. Here we go. So hash, we're going to want to set, all right, I'll have to do something quick here, but I'm going to say plus equals 1 here. So for every pairing that we find in here, we will insert a new pairing, which means I need to do hash.new 0. So we need that default value of 0 to be present. So I think I can kind of just throw all this away. Don't care about that anymore. Oh wait, no, how does this, no, common element is B. Oh, can I still infer how many times elements occur? Because, no, I can't, can I? So I was thinking if I just stored the pairs in a hash, I'd still be able to figure out how many times they occur. But if they occur on the edges, oh, wow, thanks for coming out. If they occur on the edges, we have so the issue is that I'm seeing is that I still need to count the number of times each element occurs. If I count the pairs, then I'll have double counted all of them except for the elements that appear on the edges. Oh, but the elements that appear on the edges are always the same. They don't change because we're only inserting in the middle. So I know which ones they were. So I think I can still get out the other side of this. Okay. Whew. All right. In that case, I can still do this. We can still do this. But we need to preserve the at least the start and end. So we can say start, end, equals template, split or we'll just keep those around for later. I don't know why I bothered to do that just there, but it's gonna be difficult to tell if we get this right. But so new hash is going to be a new hash. Probably should have, this is where I regret not implementing this as like an immutable struct type thing with operations on it. I did that a lot last year. I've only done that for like one puzzle this year or something. And I currently regret not having done it, but I think we can just push through. So then we go existing hash each pair, and for each pair we look up its rule. The other thing I thought of doing was insert nils at the front and back, and then have like a case where we don't do anything as we iterate over the pairings, but I don't see any value in doing that. Or I can just insert them at the end, into the hash at the end. I don't know, it doesn't matter. Rule is rules for this pair. AB equals blast the pair apart. And then in the new hash, we increment a rule. I guess we want to call it insertion, right? I'm just calling it I. So we increment that one, and we increment I, B. And then we, at the end, we set hash equals new hash. And now this code's totally borked, but let's just put a binding prime here. And I don't know, let's just focus on this one for now. Line 10 is giving us some issues. What? Pair is a hash, yes. Hash is an integer, a really large negative integer. What am I? Oh, I'm calling the hash method. Cool. So now we should have a hash that contains tons of garbage. This isn't what I wanted. Amazing. Amazingly not what I wanted. Truly, truly incredible. Whatever I just did was very funny. Let's get into here and see what's happening. Yeah, yes, it is pretty. So A is, and B is right. Okay, so that's the mistake I made. I'm iterating over hash. And I meant to iterate just over its, oh, well, that's funny, made a mistake. So it's a pair and a count, and we want to increment these by count. All right, well, convenient. That uncovers something. Now do we have something that looks more like what we want? Yes. Amazing. Now I'm just trying to think about the best way to turn these into counts. So we know I want to turn it into a tally of how many times each one occurs. So it's like hash keys flatten unique is a list of all the characters that appear in here, and we should be able to iterate over I want to map them to like an account. I guess I only care about their counts, right? Because I need to subtract the minimum from the maximum. So I don't care about this. All I care about is the number of times it appears, and it's going to appear hash dot sum k v k includes x was janky, then v else 0. Not includes, include. Ah, yes, it's true. Hashes are extremely useful in this. I agree. Yeah, especially Ruby's hashes where we can do more, we can put things like arrays and stuff in there. Very handy. So, oh, but we forgot we needed. So we should be counting everything twice. We have 2 odd numbers though. And I'm sure those map to our N and B, the starts of our start and end of our test string. And yeah, of course they are. So what's the least hacky way to just inject these in here? X equals start 1 0 plus X equals end 1 0. Okay, there we go. That's not good, but it should work. Counts equals that horrible thing, and then it's counts.last minus counts first. Oof. Oh, and we got divided by 2. No! Dang. Well, that's awkward. This is going to be not trivial to debug. Expected. I mean, let's just take a look at what we've got in here. I mean, I guess we can also do like a single step and look at how much this looks like the right answer. See if that tells us anything. So our counts are think of the sequence. What does the count of subsequences look like, and how does that? And how does the way you count them? I mean, I understand that I'm counting all but the first and last occurrences twice, so I divide by 0, and I understand that I need to add back in those first and last occurrences, which is why I've done this thing here. If I want to then divide by 0 evenly, or I can, or yeah, divide by 2 evenly, I mean. Is that what you're getting at? I thought I did that part correctly. Or do I need to, oh, do I need to divide them by first? I need to divide them first, right? No, that's gonna give me the same answer. That's how arithmetic works, right? Counts that last, divide by 2. Yeah, this is just gonna be the, I've obviously done something incorrectly though. Yeah, I almost made that mistake, or I almost didn't realize what you're suggesting. But this isn't gonna help me, because I think I've done that part right. Okay, this is impossible to read. Let's try and, or where do I want to break this? Here, then we can kind of break it up so it reads a little better. What is going? Where's the? Oh, I did this. Oh, I didn't put the. Aha! Code formatting to the rescue. I mean, that's going to help. Or no. Hash. No, that's wrong. That's not where that goes. I did that. It was in the right spot. I don't know how to format. I don't know how to format this in a way that's not awful. But it's the number of occurrences where I find it in pairs, plus 1 if it's the start or the end. Get rid of these here. Obviously I made a mistake. Let's see if it does one step correctly. We should be able to do that by inspection. So it has now counted. We're just gonna go inside of this object so that we can play around with it. So inside of here now, print that. We should have one occurrence of NC, and we have one occurrence of NC. We should have one occurrence of CN. We do. We should have one occurrence of NB. We do. We should have one occurrence of BC. We do. We should have one occurrence of CH. We do. And one occurrence of HB. We do. Okay, well that was not especially useful, but we can just do it all over again. So now it says we have 2 occurrences of NB. Correct. 2 occurrences of BC. Correct. 2 occurrences of CC. Incorrect. Two occurrences of CN. CN. Incorrect. Oh, sorry, 1 occurrence. Oh, I'm failing at reading. 1 occurrence CC, 1 occurrence CN, 2 occurrences of BB. Okay, so now that's right. 2 occurrences of CB, 1 occurrence of BH, and 1 occurrence of HC. I mean, that accounts for everything. That suggests something else about my 1749 minus 161, the expected outputs. Maybe it's in your converting to letter counts. Oh, of course. I'm not counting double pairs correctly. Thank you. Thank you. Good. So we can. So what we actually want to do is we want to count the number of times that X appears in the key, and then multiply V by that. In fact, we don't even need to. Thank you. All right, so now that that's working for this one, let's see if it works for day 2 as well. Oops, I need to remove this pry. No failures. Where'd this pry go? That's awesome. Everything passes, and then we should be able to install part 2. That was a good trick. There we go. Amazing. Love it. Thank you, Nathaniel. All right. That's day 14. I'm going to cut the recording here and then immediately start doing day 15.